Alright, we are live. Let me check the microphone. Okay, so yesterday we just decided that we were done with the reading of the code, reviewing of the code. I needed like some actual action, like writing a code, writing a piece of code. So I decided like to go for writing a new example for the Forge engine. So that is what I'm going to do. So yeah, that's how we started this. So what I did was to copy one of these projects just to inherit their settings, and I edited them all to match the naming, and then I added two files to it. So I'm going to try to come up with an interface for the renderer, a C++ interface for the renderer that is going to be way better than what we had here on the other examples, like this material playground example. So that's gonna like offload some of the work to this render class. And then we read about the app, like how the interface works. That was pretty simple. We just read the documentation. The documentation is out of date, but it is still is some amount of documentation. So yep, that's how we started this, and I am going today to start actually implementing some of these functions like the init function, the load, other stuff. Maybe we could get something to draw like just an uh, empty screen, empty window. So this is all from scratch. I will get help from the other examples, but yeah, I will try to make it from scratch. Alright, so I'm gonna start by also we're using ESTL as dated. The reason for this is that the ESTL does have optional here, yet the stud didn't have optional with their settings of compilation. So I don't want to increase the standard. If it's on 11, I'm gonna stay on 11. So I also did get my header file to include. That was just adding the settings. So that is my ESTL optional. I'm going to have an optional render. This is just for delayed construction of the render, as we read on the iApp documentation. It says that the render should be here. The render should be initialized in init app. We don't have init app anymore because I don't know why. So the documentation is old, but I'm assuming that init app was merged to init here. So I'm gonna just delay the construction of this renderer to initialization through the call of init. So that is why I'm using an optional. So I believe this has an in place. Yeah, this does have an in place. Alright, I'm going to in place a renderer there. So what my render is going to my render is going to have a unique footer. There this is. It's going to have a unique footer. Of course, ESTL unique footer. Also, we had some questions from the last time. I didn't like Okay, I'm also realizing that we're going to have naming conflicts here. Uh, both my renderer and their renderers are called render. However, my renderer does have a namespace, but theirs don't. So that is of no use. I need to change my name here. So what should I name it? Let's see. CP render, maybe? No. I don't like this because what I'm actually doing here, like if I were to go and do it like this, maybe. This is kind of a that is kind of a namespacing. I have a namespace here, so maybe let's. I don't want to put my name there, so I'm not doing that. Render. What should I name this? After rendering interface. What should I call this? Come on. Forge render. All right, let's go with that. Oh, that's misleading because this is actually for the Forge render. Uh, yeah, I'm going with that. Why not? Okay, so it's gonna have a renderer inside it, a unique footer to render. So it's gonna have also a deleter, which is going to be uh destroy renderer maybe. I don't know what the name was. Destroy renderer. Do we have something like that? Renderer. No, we don't. Let's see. Let's see from other examples. What do we have? Renderer. Come on. Really? We don't have a single. Oh, no. Pure renderer. I'm assuming that the instruction is at the bottom of the code, so I am going. Okay, alright, we'll render target now. Destroy render target. No, 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 no. Those are not what I'm looking for. So I'm assuming this will. Okay, remove render. That is my interface here. So they could type of the pointer to remove render. Render putter. Okay. Yeah, I am not going with there. This shouldn't have been. Okay, no, I did the wrong thing here. That is actually renderer. Wrong file. This is what I meant to do. Okay, I'm not using their naming conventions. I know, but I'm not really happy with their naming conventions. Alright, so this is my render putter. Alright, so my public constructor should be constructing that. My render putter is constructed by init render. So here is some other place that their C interfaces are not really designed to be used in C++ because init render. Yeah, these are our problems. Pure render settings. What is in the settings? MAPI shader target. MGP mode. Okay. Anyways, those are not of our interest here. What is, however, is that. Okay. So I'm going to put a static function here. Create render, create render. Alright, and what I'm going to do is uh, so I'm assuming you're having some trouble with my stream. Seems like there's some buffering. Yeah. I'm gonna fix my internet and come back. That is in case we need a render descriptor. And settings, and the p-render and the name. Alright, we are also going for a name here. What should I call this? Construct? Nope. Let me check this one here. So it is a const render descriptor. Yeah. I don't know what to do about the naming here. So I'm not sure. Yeah. My problem here is I'm not sure how they're using. Let's get into their render. Which render? App name. I'm not sure how they're. Okay, they're meant to find the app name, so they're not relying on the lifetime of this app name. So that is nice. So yeah, I'm getting a render descriptor reference here. This didn't have to be a reference. Why not? Descriptor. And then I'm going to get a name which is going to be stl string name, and that's going to be all of it. Okay, and we're going to have a footer here. We're going to pass render footer to the to our init render, and of course the CS cycle my voice. So yeah, and then we're going to return the render footer. That should be fine there. I don't know why there's a problem here. What is it saying? Argument of type render interface render footer. So this hasn't yet realized render. I realized that I have renamed this to IYP render. I believe that is a problem here because it is thinking that this is a render interface render. I have my unique footer included there. That's the problem here. That this version has no storage class of type classifier. What? Who asked you to search inside your render interface? Yes, sir. I'm gonna just compile this. Okay, no, I'm not gonna compile that. There's a problem here. That is that. And we're going to. Okay, things seem to have been fixed. I just close that thing. Alright. So I'm gonna create a renderer and pass it there, and of course a reference to our deleter here. So I'm just gonna try not to do it, try to do everything REAI. I don't wanna like handle the destruction of these separately. So that is what's going to be happening here. So, anyways, we have our renderer here. Our create renderer just gets a descriptor, which I'm going to pass nothing to it, as we did there. I'm going to pass a blah blah name. These are just experimental. We will probably get some input in our constructor for these. Let's see if this compiles. Doesn't. String is not a member of the STL. Of course, I haven't included the string header here. Let's see if this compiles. It still doesn't. Syntax error. Am I missing some parentheses here? Or yeah, no. Am I? Create render here was called. That is static. No problems there. So I guess this is the problem here, which I'm going to see. Okay, I'm not that. See if it works. If it works. Still no. Where is this problem? Okay, it's not even in this file. It is here. So that's my optional render. I'm placing nothing to it. I'm placing and calling the default constructor there. So I'm default constructor constructing my render here, and yeah. My connection seems fine, but I'm experiencing some buffering here. So it just compiled. I will try to now like get a simple pipeline up and try to draw maybe just clean the screen with some other color. So let's see. Maybe this is a too big of a example to copy things from. Yeah, I'm going to copy a lot of things here. Okay, let's see what they do in the initialization. So they're loading some resources I'm not going to do at the moment. That should be just fine. Program directory. I'm not going to do any of the resource handling right now because I don't need it. There we're checking the instruction. Alright, so that's where you would wanna throw, which is here. So if my construction fails, I need to somehow uh, tell my caller that there's an error in my construction. So that's what I'm going to do here. So if my render footer is null, I am going to ESTL runtime exception. Let me just check that. I don't know why they would. Yeah, there's one reason. Alright, what is it? I agree. Okay, that is not what I'm looking for. Runtime error. That is what we're looking for. Runtime error. Yep, runtime error is what we need, and it is not telling me. Are they themselves using runtime error from S2? Because that is what I'm seeing here. Like, this seems to be part of their code, and they're throwing stupid runtime error. So does that mean I have to use runtime error from S2? It is part of the STL code. Extra path.h. Let's try to fix it. What I'm going to do is to maybe maybe they have it. Let's just give it a try. They don't. Exception. Maybe yes, still exception no, exclude exception no. So we're going with the with our except here and execute runtime error. And I'm gonna throw a runtime error which is going to say failed to initialize my render. Okay, if I can actually type something. Alright, that is how we're going to handle the exception on our render part. And things are safe now. Okay, we get a render running. Let's see if we are actually constructing a render, because last time we didn't have the exception being thrown. So it could be just us not rendering anything, not constructing a render. Okay, that seems to have worked. So what else do we have to do? Queue descriptor for commands. Okay, type graphics. This we are going to do. Obviously, it's a must. So this is technically for making a command list and describing what you need to do on the draw calls. So yeah, that is what that is. Neptune. We're not going to do any of those. Right, let's go step by step then. We do need the command, command queue, command descriptor, and command queue. So I guess we're going to have to do these. This is going to be a lot of just boilerplate code trying to handle these. Okay, the queue descriptor. What is it doing? Add queue, add command. Alright, so one thing I'm going to do is I'm going to include first our system int. So we have uint pdr. So I'm going to provide my own interfaces for these. So queue descriptor here, queue type graphics, flag init marker profile. Alright, and then we have add queue renderer. So it is adding a queue here. And then we have pool descriptor, command pool descriptor graphics queue, which is that. And then what other options do we have here? We need all these options. GPU timeout, disable GPU timeout, PL9, Q flag, Q type. So there are two ways of approaching this. One could be that I would reduce our interface, like restrict our interface to like add in a graphics command. So that what that would do would be like getting the queue going, getting the pool going, and just getting us a command and passing us the footer to that command. That would be one way of approaching this, but that would just limit our options here. So I'm going with limited options here because I haven't seen any other use of this. For now, we could always expand our interfaces. So, what we're going to do, we're going to return to new int ptr. So this is just a putter, this is just an integral type that is large enough to hold a single putter. So that is what our create graphics command is going to do. Command, yeah. All right. So we're adding a new interface to our IYP renderer. So I'm wondering whether we should we should not even sorry about my throat. I'm wondering whether we should actually allow the user to create this command, because as it seems it is being done by default here. That has been done by default. So maybe we don't really need to bother the user by this. And what else do we have here? Add pins, add semaphores, image count. So what is this image count? And why do we want image count here? Man count. Do we have several commands here? I'm seeing only one command descriptor. So p descriptor, pointer to descriptor there. You have pointer to renderer, command count, p commands. So I believe it is it's a putter to putter to putter. So they're creating many commands here. But this is actually being used to used in specific ways. So yeah, I am going to add an interface here. To create command graphics command. What is it going to be? TP commands. What is it? G frame index. That is weird. G frame index. What is that? Graphics frame index. Is that it? Acquire next image. Oh, maybe that is what that is. Let's see here. Image count 3. Render complete fences, semaphores, and project view uniform buffers. So what I believe they're doing, I believe they're going to have like 3 render targets and a swap chain of 3. Where are they actually? Yeah, add swap chain. G image count. So here, so they're creating a swap chain of 3. I believe that's going to be the same everywhere. So they're just telling the renderer that I'm going to have like 3 render render uh, render buffers that you're going to swap between. That is what's happening here. So that is our G image count. Okay, I'm going to make these template parameter. That is what I'm going to do. Swap chain length. All right, that's how I handle that. So yeah, I don't think there's a need for this. And on their draw call, here's their draw call. What they do on the draw call is this. You see, they're getting the current frame index and they're getting the render target from it, the semaphores, fences, blah blah, and they're getting the proper command here, and they're starting to draw on that command. So I will provide the draw interfaces. Maybe I'm not sure if I'm going to support every single draw here on my interface. My interface is going to be as small as it should be. So creating of these commands are going to be done here using this parameter, which I'm going to default to 3 as they've done in their examples. So what I'm going to do here is create three commands. That is what I'm going to do. For that we need a stl array. Let's include that. That is going to be our array here. ESTL array of button, array of unique footers, I believe. But then I wouldn't be able to like, yeah, why not? Yeah, why not? Let's do this. So unique footers of what? Unique footers of command. I believe the type of this is command, but doesn't hurt to double check. Yeah, the type of that is command. So we're going to have an array of unique footers to a command, and it's really marvelous that this is not conflicting with any other built-in types. Anyways, sorry about that. So we probably have some way of deleting our commands. We have our commands. Okay, remove command N. That is what we need to do. That is our deleter there. I bet it needs a render. Yeah, it does. So here's the trick to do this. This is not going to be that's going to be size T. And for size T, I'm going to include stud just to def to def. Okay. So we have size T here. That's the number. That's the length of our swap chain, and we need a command for each swap chain. So that is going to be an array of that length. We need a deleter for this, which is okay. We need to write custom deleters for these because these deleters are relying on the render. So that is how we should do this. We should write custom deleters for this, and for that I'm writing a custom struct here, which is going to be called hold renderer, maybe parent ref, no, owner ref. Okay, so the rest of, so what this is going to have in it is going to be a reference to IYP render of type this. Alright, owner. So I'm going to use this owner to access this render here. So so like, because this pattern is going to like come up everywhere, almost everywhere. So what I'm going to do here, like for example, I'm going to write deleter. What is it? Command deleter. Command deleter. Okay. So I need that reference here if I'm going to delete this, because on delete this is going to need to access yeah, access this renderer inside me, this renderer. So yeah, that is the reason I'm going to do that. Like, look at this, we need that p renderer here. So yeah, but the question here is, my renderer is at the moment private, and if I'm going to access the render putter as private member, I will need to, yeah, I will need to I will need to make this a friend. Make this a friend. And I don't want to start writing friends all over the place. So maybe this should just hold the smaller thing that we actually need, which is going to be, nope, that's not gonna be good. Hmm, what do we do? Do we have access here because we're in the we are still in ourselves? Let's check this operator. So I'm writing an invocation operator. This is going to be called on delete. Okay, come on. Can I type a single? Oh, I am so dumb. Alright, so that's our operator. So that's our deleter. Let's see if we do actually have access for this. Let's see. Alright. So I'm going to get the render putter and get that. So I'm going to delete the command here. So I'm going to copy this function name from here. That is going to delete my command. So next it's going to ask me to give it a command count the command. So it's going to delete a bunch of commands rather than one. So maybe I'm not going to make this an array. Maybe I am not going to make that an array. I'm going to make that this. That is better, I believe, for many reasons. This is the type of our deleter. Let's put it there. And our commands are going to be here. Oh, come on. Commands putter. Let's put an S there just to get the point that. And that is our deleter there. So yeah, I'm not sure if I am supposed to use that brackets there. We have 40 minutes in already. Anyways, let's just move on. Let's move on. Let's not wait here. I'm going to get what? What am I going to do? Okay, command putters. So I'm getting command putter and I'm deleting it. That's what this function is supposed to do. Oh, okay. Alright, I'm writing the parameter in the wrong parentheses. Alright. Okay. There we have our command putter. We're gonna put it here. Close that. That is going to be that. And our okay, that is seemingly the interface. Or do we need something else? Okay, we need the image count, which is our swap chain length. There we go. That is my deleter there, and I am going to construct my commands putter right now. And the way I'm going to go about constructing this command putter, there is going to be a bunch of boilerplate code that is probably just definitely the same. Like I am going to like write a create command here. So this is going to be almost the exact same code. Create render, it's going to be create commands, make sure to put that there. And what it's going to get is a putter to render, which is going to be renderer putter. We know that it's not going to use the lifetime, to rely on the lifetime of the constructor as well. A ref here too. So yeah, so we are now from there here on we're going to be sure that when we're passing putters, we don't actually. Maybe this could be a reference. That could be a reference. Why not? So const render reference. It's not going to be const, I believe. It's going to be a render. So we're creating render here. All right. We're creating a command from our renderer. Uh, what is going to be our constructor here? Add command in. There's our constructor. Add command in. So we're going to have a command putter here. Command putter commands. That's our commands. Going to pass this command to. Let's see what this requires us. Renderer, which is going to be reference to our renderer there. Alright, what else? Command descriptor. That I'm going to get command descriptor. That's what I'm going to get as input. Command count we have, which is the swap chain count, swap chain length, and then we have our commands. And I believe this is going to be that, like so. That is going to be like so. This is weird, but this is actually what this is. Alright, our deleter has to be modified as well. So I believe this is const as well here. Weird stuff we're encountering here. And since that's a copy, that should be fine, I believe. Maybe not. Anyways, this is gonna give me some errors. Let's get into it and fix it right away. This is const here, so is that. Alright, should be fine. And so yeah, that is what we're doing here. So this is our deleter. It gets a command putter, commands putter. Let's fix that as well. So it gets a putter to several commands, and we could have a little using aliasing here. Command. So a command is going to be command putter. That is what the command is, I believe. Is it? That is going to cause confusion later on. That definitely is going to cause confusion later on. I'm not going to use that. Yeah, let's not write that. Alright. So what this is going to return is a putter to a putter. I'm wondering which of these putters I can make const. Here none. Okay, let's see what else this one needs. So a reference to this. This is not a. They're not providing us with good interfaces here. Maybe I was better off. Let's see this add cannot. Let's not see that. Let's see this command constructor here. Remove command. Is there a version that does not take n here? Is there a normal version of this? Yeah, remove command and add command. Why not just use these? I'm gonna do that. I'm definitely gonna do that. We're going with the old approach, with the studary. Don't confuse yourself, not studary. Don't confuse your users, but by uh, such interfaces that are not compatible with anything. So I'm going for array here. This is going to be an array of that. So here I'm just like letting the construction do its work. This array is going to handle everything. I don't need to worry about anything like that. So yeah, command deleter. There's no commands anymore. Command putter. I don't have the second putter. Simple as that. Remove command. There's only one command I need to remove there. That is that. That is simpler. That is way simpler. This is going to create a single command. It's going to give me a single putter. And there we go. We don't need this. And that is named command. Simple as that. That is going to be add command. And I believe they're not checking for any errors here, so neither am I going to. Alright, that is our create command. Seems fine. No error handlings and return command. That is going to work just fine. So we need to just add a command descriptor here. Const command descriptor. The type would be cmd descriptor, I believe, if I'm understanding their naming conventions. Not pointer, but a reference. I'm going to give that a footer, I believe. So that's going to be like that. Things should work. I haven't compiled this for a long time. I believe this is going to compile, but let's try that first. I don't see any errors. Function returns. What did you just say? Function returns function. No, it doesn't. Void operator. Blah blah. Owner. Okay, I don't need that there. But this is not that error. Interface 45 4. Function returns function. See references being compiled. Doesn't return function. What do you mean? Void operator. Operator. Yeah, that was a problem. Okay, this compiles. That is nice. That is just sweet. And yeah, what I'm going to do is move on. Let's just actually uh, populate this array with something. And to do that, I am going to write lambda. Lambda that is going to populate my array here. Okay, so maybe this is not going to be a lambda here. It's going to be rather a function because it's going to be huge. Not huge, but it's not going to be small. So what do we need? We need what do we need for construction here? We need to render. We need command descriptor. So for command descriptor we need other stuff. So before we can actually go about writing a constructor, uh, actually constructing these, we need to construct a few other stuff. Those stuff are going to be queues, command pools. So I'm assuming every single command is going to need all of these. That is what's happening here. The queue descriptor there, add queue, blah blah, pq. I will probably end up like having multiple headers here. A single header doesn't seem to be enough, because I would probably want stuff like modulation in my code. So yeah, so I believe these are the same object. These are one single object. So I have three of this object, which is a queue, a command pool, and a command. So that is what I'm going to do. I'm going to create a new structure here. We have 8 minutes left of this. This is going to be slow progress. That is that. Okay, so we didn't do any extra code. We actually do need these. We do actually need these codes here. So I'm going to put this up there so we can actually have code relevancy. Alright, create command and this is argument. So these two are relevant. Alright, so this is going to be my structure. It's a command. Let's call it graphics command because that is what we are aiming at. So it's a graphics command. So what does a graphics command have in it? It would have a command there, and we have an array of commands with the length of swap chain length. Alright, so what else does this command of us need? It would require a queue, which is going to be a unique footer of queue. Maybe I could move these inside that. Because that is the smallest scope we actually need that to be. Let's make this a class and have a public interface here. Alright, so we need a queue. I'm gonna avoid putting graphics behind each one of these because we have it in type. The type just says it. And what else do we need here? We need a pool, which is command pool. Command pool. Is that a type? That is a type. And of course, the type just speaks it. It is a pool. It's a command, so this pool is command pool. I don't need to specifically just say that. Alright, let's copy these. I'm going to try to abstract them. Yeah, we need to extract them further. Uh, 56 minutes in we are. So the way I'm going to abstract this probably, so the problem here we have is I need to write this boilerplate code for each type I need. Alright, queue, command pool, command, all of them need a create command function like this. That is just to fit well with our unique pointer interface. And so yeah, I am going to write these two for every single function, every single type, every single type that I have. So I will try to like kind of avoid doing that by creating some abstraction here. So let's see how these actually work. So I'll create command here. Let's actually specialize this for every single use, and then I will go and actually abstract our three implementation of different types. So this is going to be called, let's start from here. Our first type is going to be queue. So this is going to be create queue. And our create queue, what is it going to do? It's going to get a, let me put that there, add queue there. It's going to return a queue command. Is going to be renamed to, okay, not like that. Oh no no no. I don't know how the multi-select here works. I know in VS Code, if you were to like press Control D, you would multi-select all the usages of this queue. Command descriptor there. This is going to change to queue descriptor, I believe. Yeah, this is going to be queue descriptor right there. We of course need our renderer there. So it's going to be renamed to queue descriptor. So as you can see, this is just boilerplate code, but we got to come up with some cool design to abstract all these. I don't want to write type every single of these. So I believe two of them are going to be enough. Two concrete classes are going to be enough for our abstraction. Anyways, let's just get this going as soon as possible. Like we have 2 minutes left. I'm going to like get this code to compile, and then tomorrow I will probably go about abstracting these. Okay, queue deleter, that's the name. So it's probably going to be remove queue. It's probably going to get a queue putter, blah blah, and it's going to be queue deleter here. That is going to be commented here, commented there. Alright, queue command. We have to create command. We have to, okay. This has to work. So I believe I am also calling these deleters, so those are actually being compiled. We have our queue there. I believe the code is fine. It's not fine, but it's got to work. Okay, let's change this to queue. Let's see. So yeah, we literally have three duplicate codes here. Two two pairs of duplicate code. I don't like this. So I have a bug here. I will probably have it here too. So tomorrow I will start by coming up with an abstraction that is going to solve our problem. And the code actually compiles, so that's a good sign. Let me check. I am replacing the renderer there. Yeah, the code does compile actually. Let's put a put in let's put some. Let's make this Q and just make sure that this isn't going to compile. And it compiles. So yeah, the code is not being compiled right now, I believe. Unless these are like sure, oh, okay, that is in the create. Yeah, yeah. I am not testing the create ones. Let's make this const. That should fail. And neither did that. That didn't fail either. Let's show this footer. Alright, that did fail, but what does it say? Public file was generated. Syntax qualifier use more than once. That is that. What I'm doing here is just I'm trying to make sure that those functions are being actually compiled, which they seemingly are not. Because probably I am not properly constructing these. I am constructing this one, but not that one. So I'm going to construct that one too. Now put I won't be able to actually construct that for now. Alright, anyways, I might have some problems here. My problem would probably be this owner thingy, which could be helped by adding a get renderer here. Yeah, I will get to that tomorrow if I encounter any compilation errors. Let's fix this code. That's how the code should look like. And yeah, I will tomorrow finish the code on the pool and get all commands actually being constructed and deleted. So if you have any compilation errors, we're going to find them first, and then I'm going to go about abstracting these three. Yeah, they're going to be three. We're going to add one for the pool. Yeah. Alright, that's enough for today, I guess. We are 3 minutes over time already. See you next time.